Hello dear students, glad to meet you again in this session 1.9. In this session 1.9, we are going to discuss about percentage composition, empirical and molecular formula from chapter 1, some basic concepts of chemistry in grade 11. In session 1.1, we have discussed the importance of chemistry and nature of matter and its classification. In session 1.2, we have discussed the 7 basic units of SI system, its definition and its symbol. In session 1.3, we have discussed the physical quantitative properties of matter, and under this heading, we have discussed about mass, weight, volume, density, and temperature. In session 1.4, we have discussed the uncertainty in measurements, and under this heading, we have discussed about scientific notation, significant figures, precision and accuracy, and dimensional analysis. In session 1.5, we have discussed about the laws of chemical combination. In session 1.6, we have discussed the postulates of Dalton atomic theory, atomic mass, molecular mass, and formula mass. In session 1.7, we have discussed the mole concept, Avogadro number, molar mass, and molar volume. In session 1.8, we have discussed about gram equivalent mass for oxidizing and reducing agents and for acids and base. Learning outcomes. Students, at the end of this session, you will be able to understand what is percentage composition, define empirical formula and molecular formula, distinguish empirical and molecular formula, and calculate empirical and molecular formula for a compound. Before getting into today's concept, let us understand what is mass percentage, that is percentage composition, and the concept of purity. Students, in this slide, we could see 3 boxes, right? Just by looking at these 3 boxes, we could easily say that the percentage of apple in the first box is 100, and in the second box it is 50, and in the third box it is 20. Let us consider the third box. If we notice the composition of the fruits, it contains 20% of apple and 80% of mango. We know that the amount of matter present in a substance is called mass. Here, the amount of apple present in this box is 2. If we want to express this in percentage, we can say the mass percentage of apple is 20 and that of mango it is 80%, right? You could understand the concept of mass percentage now, which is nothing but the percentage composition of the particular substance. Now let us correlate the percentage composition with the concept of purity. If you look at the first box, the entire box is full of apples. No other fruits are there in this box, right? So the first box contains 100% of purity with respect to apple. Likewise, the second box is 50% of purity and the third box is 20% of purity with respect to apple. Now, hope you could have understand both the concept of percentage composition and the concept of purity. Let us apply this concept to the elements present in the chemical compounds. Percentage composition. If an unknown compound is given, we need to know the constituent elements and the percentage composition of the constituent elements present in the compound. Even for the known sample, we need such information to check whether the given sample contains same percentage of elements as it is in the pure compound. So, to check the purity of a given sample, the information regarding the percentage of a particular element present in a compound is required. For example, the percentage of hydrogen and oxygen in water can be calculated as follows. We know that the molar mass of water is 18.02 grams and the constituent element present in water is hydrogen and oxygen. To find the mass of an element, we have the formula mass of the element in the compound divided by molar mass of the compound into 100. To find the mass percentage of hydrogen in water molecule, we have 2 hydrogen. So 2 into 1.008 divided by 18.02 into 100. To find the mass percentage of oxygen in water molecule, we have 1 oxygen in water molecule. So 1 into 16.00 divided by 18.02 into 100. So the mass percentage of hydrogen is 11.18% and the mass percentage of oxygen is 88.79% in water molecule. Let us take another example, ethanol. Its formula is C2H5OH. To find the molecular mass of ethanol, we have to add the atomic mass of the element present in ethanol. Here we have carbon, hydrogen and oxygen. There are two carbon atoms, so 2 into 12.01, which is the atomic mass of carbon, plus we have 6 hydrogen over here, so 6 into 1.008 grams of hydrogen, which is the atomic mass of hydrogen, plus, and we have only one oxygen, so 16.00 grams, that is the atomic mass of oxygen. When we add all these number, we get 46.068, which is the molecular mass of ethanol. We know the formula to find the mass percentage of an element, which is equal to mass of the element in the compound divided by molar mass of the compound into 100. First, let us see the mass percentage of carbon. Since we have 2 carbon, 2 into 12.01, which is the atomic mass of carbon, divided by 46.068, that is the molar mass of the compound, into 100, which gives 52.14 percentage. Next, to find the mass percentage of hydrogen, we have 6 hydrogen, so 6 into 1.008 divided by the molar mass of the compound is 46.068 into 100, which gives 13.13 percentage. Finally, we have to find the mass percentage of oxygen. We have only one oxygen, so 1 into 16.00 divided by 46.068 into 100, which gives 34.73 percentage of oxygen. So we have 52.14 percentage of carbon, 13.13 percentage of hydrogen and 34.73 percentage of oxygen in ethanol. If the mass percentage of various elements present in a compound is known, its empirical formula can be calculated. Empirical formula. The empirical formula gives the simple whole number ratio of atoms of the various element present in a molecule of the compound. The empirical formula of glucose is CH2O, which shows that carbon, hydrogen and oxygen are present in the simple ratio of 1:2:1. Empirical formula mass. Empirical formula mass of a substance is equal to the sum of atomic masses of all the atoms in the empirical formula of the substance. For example, empirical formula mass of glucose CH2O, which is in the ratio 1:2:1, is equal to, what is the atomic mass of carbon? 12. Since we have one carbon, 1 into 12, that is 12, plus what is the atomic mass of hydrogen? 1. We have 2 hydrogen. So 2 into 1 plus what is the atomic mass of oxygen here? 16. So 16. When you sum up all these atomic masses, we get 30, which is the empirical formula mass of glucose. The next concept is molecular formula. The molecular formula of the compound can be defined as the formula which gives the exact number of atoms of various elements present in the molecule of the compound. So what is the difference between empirical formula and molecular formula? The empirical formula shows the simplest ratio, but the molecular formula shows the exact number of the various elements present in the molecule. For example, if we take glucose, the empirical formula of glucose shows the simplest ratio of the constituent elements here, carbon, hydrogen and oxygen, in the ratio 1:2:1. But the molecular formula of glucose gives the exact number of atoms present in glucose. That is, it has 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So the molecular formula gives the exact number of atoms present in a compound. Relationship between molecular formula and empirical formula. Molecular formula is equal to empirical formula into N. That is, molecular formula of a compound is a whole number multiple of the empirical formula. The whole number can be calculated from the molar mass of the compound using the following expression. Whole number N is equal to molar mass of the compound divided by calculated empirical formula mass. Understand this concept empirical formula and molecular formula with an example problem. A compound contains 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Its molar mass is 98.96 gram. What are its empirical and molecular formula? The elements present in this compound are carbon, hydrogen, and chlorine, and they have given the mass percentage of each element. For carbon, they have given 24.27 percentage. That means it has 24.27 parts of carbon in 100 parts of the compound, and the atomic mass of carbon is 12. So to find for one part, we have to divide the percentage mass percentage by its atomic mass. So 24.27 divided by 12, which gives 2.02 for carbon. In the same way, we have to do the calculations for hydrogen and chlorine. They have given 4.07 mass percentage. So we have to divide 4.07 divided by its atomic mass 1, which gives 4.07 for hydrogen. And they have given 71.65 as a mass percentage for chlorine. That means it has 71.65 parts of chlorine in 100 parts of the compound. So we need to calculate for one part. For that, we have to divide 71.65 divided by its atomic mass 35.45, which gives 2.02 for chlorine. So in the first step, we have to divide the percentage of each element by its atomic mass. In step 2, to find out the simple ratio, we have to divide the quotients obtained in this relative number of moles by the smallest number among them. Which is the smallest number here? 2.02. So we need to divide all these quotients by the smallest number. So 2.02 divided by 2.02 gives 1 for carbon. 4.07 divided by 2.02 gives 2 for hydrogen. 2.02 divided by 2.02 gives 1 for chlorine. In step 3, we need to write the empirical formula by mentioning the simplest whole number ratio after writing the symbols of the respective elements. Thus, the empirical formula of the above compound is CH2Cl. Now, we need to find out the molecular formula of this compound. In step 4, we need to find the value of N. The experimental molar mass is given in the problem as 98.96 grams. We know the empirical formula is CH2Cl. To find the empirical formula mass, we need to sum up the atomic mass of the elements present in the formula of the compound. To find the empirical formula mass, we need to sum up the atomic mass of the elements present in the formula. Here we have 1 carbon, so 12 into 1 plus 2 hydrogen atoms, so 1 into 2 plus 1 chlorine atom, 35.45 into 1. And 12, 1 and 35.45 are the atomic masses of carbon, hydrogen and chlorine. When we sum up, we get 49.48 grams as the empirical formula mass for this compound. We get the value of N from the expression molar mass divided by the empirical formula mass. The molar mass given is 98.96 divided by the empirical formula mass we have calculated as 49.48. So 98.96 divided by 49.48 gives 2, which is the value of N. Finally, in step 5, we are going to determine the molecular formula for this compound. We know the expression molecular formula is equal to empirical formula into N. Just now we find out the value of N is 2. So we know that the empirical formula of this compound is CH2Cl. So when we multiply this to CH2Cl into 2, we get the molecular formula. 2 into 1 carbon C2, 2 into 2 hydrogen atoms H4 and 2 into 1 chlorine atom Cl2. So C2H4Cl2 is the molecular formula for this compound. Determination of empirical formula. Let us see another example problem, problem number 2. An acid found in tamarind on analysis shows that the following percentage composition: 32% carbon, 4% hydrogen and 64% oxygen. Find the empirical formula of the compound. The elements present in this compound are carbon, hydrogen, and oxygen. They have given the mass percentage. They have given 32 percentage of carbon, which means 32 parts of carbon in 100 parts of the compound. And we know the atomic mass is 12. So to find for one part, we have to divide 32 divided by 12, which gives 2.66 for carbon. Likewise, we have to calculate for hydrogen and oxygen. So 4 percentage they have given. So 4 divided by 1, that is the atomic mass of hydrogen, which gives 4 for hydrogen. For oxygen, they have given 64 percentage. So 64 divided by its atomic mass is 16, which gives 4 for oxygen. So in the next step, step number 2, we have to divide the quotients that we obtain in relative number of moles by the smallest number among them. Here, which is the smallest number? 2.66. So we have to divide all the quotients by 2.66. So 2.66 divided by 2.66, which gives 1 for carbon. Here for hydrogen, 4 divided by 2.66, which gives 1.5 for hydrogen. 4 upon 2.66, which gives 1.5 for oxygen. When you look at these simple ratios, we could see the decimal numbers like this. So if we get decimal numbers like this, we have to multiply it by an even number, that is 2, just to convert it into the whole number. 1 into 2 gives 2 for carbon, 1.5 into 2 gives 3 for hydrogen, and 1.5 into 2 gives again 3 for oxygen. So now we have changed it into simplest whole number ratio. The next step is to write the empirical formula for this compound. To write the empirical formula for this compound, first we need to write the symbols of the element present in the compound. So here we have 2 carbon, so C2, and we have 3 hydrogen, H3, and 3 oxygen, so O3. So C2H3O3, this is the empirical formula for this compound. Let us solve one more problem under the heading determination of empirical formula. An organic compound present in vinegar has 40 percentage carbon, 6.6 percentage hydrogen, and 53.4 percentage oxygen. Find the empirical formula of the compound. The elements present in this compound are carbon, hydrogen, and oxygen. The mass percentage they have given 40 percentage for carbon, 6.6 percentage for hydrogen, and 53.4 percentage for oxygen. If they given 40 percentage as a mass percentage, then it means 40 parts of carbon in 100 parts of the compound. So to find out for one part, we have to divide this mass percentage by its atomic mass, which is 40 divided by 12, which gives 3.3 for carbon. Likewise, we have to calculate for hydrogen and oxygen. For hydrogen, 6.6 divided by 1, that is the atomic mass of hydrogen, which gives 6.6 for hydrogen, and 53.4 divided by 16, that is the atomic mass of oxygen, which gives 3.3 for oxygen. Now we have to divide the quotient that we have obtained in the relative number of moles by the smallest number among them. Which is the smallest number among them? 3.3. So we have to divide this quotients by 3.3. Here we get the simplest ratio as the whole numbers. So no need for us to multiply it with an even number. We can write the simplest ratio in whole numbers as it is: 1 for carbon, 2 for hydrogen, and 1 for oxygen. Now we need to write the empirical formula. How we have to write the empirical formula? First we have to write the symbols followed by the simplest whole number. 1 for carbon, so C, 2 for hydrogen, so H2, and 1 for oxygen, O. So the empirical formula for this compound is CH2O. Problem number 4. In this problem, we are going to determine the molecular formula from the empirical formula. Two organic compounds, one present in vinegar, molar mass is 60 gram per mole. Another one present in sour milk, molar mass 90 gram per mole, have the following mass percentage composition. Find their molecular formula. Since both the compounds have the same mass percentage, its empirical formula is CH2O. From this, we can calculate the empirical formula mass. To calculate the empirical formula mass, we need to add the atomic mass of the constituent elements present in the compound. So here we have one carbon, so 12 plus, and two hydrogen, 2 into 1 plus, and one oxygen, 16. When we sum up all these numbers, we get 30 grams per mole as empirical formula mass of this compound. Now let us calculate the molecular formula of the compound. The molar mass given in the problem is 60. So 60 divided by the calculated empirical formula, just now we have calculated it as 30. So 60 divided by 30 gives 2. Now we can write the molecular formula for this compound using the expression molecular formula is equal to empirical formula into N. What is the empirical formula for this compound? CH2O. What is the value of N for this compound? 2. So CH2O into 2. 2 into 1 carbon C2. 2 into 2 hydrogen H4. 2 into 1 oxygen O2. So the molecular formula for this compound is C2H4O2, which is acetic acid. Now let us calculate the molecular formula for the second compound, that is for the compound present in sour milk. Since the mass percentage of the constituent element is same for both the compounds, the empirical formula is also same. Now we need to find the value of N from the following expression. N equal to molar mass divided by the calculated empirical formula mass. So 90 divided by 30 gives 3, which is the value of N for this compound. Now let us calculate the molecular formula for this compound. Since the empirical formula is same for both the compound, the empirical formula is CH2O for this compound also. What is the value of N for this compound? 3. So CH2O into 3. Now we have to multiply the empirical formula by its N value. So 3 into 1 carbon C3, 3 into 2 hydrogen H6, and 3 into 1 oxygen O3. So C3H6O3 is the molecular formula for the second compound, which is lactic acid. Here in this slide, we have given the molecular formula of both the compounds in a single table format. Students, let us recall all the topics that we have discussed in this session. In this session, we have discussed about percentage composition, empirical formula and molecular formula, and the difference between empirical formula and molecular formula. And we have discussed about the calculation of empirical formula and molecular formula for a compound. Hope this session was useful to you. See you soon in the next session. Have a nice day. Thank you.